Two other identities that we can use to simplify trigonometric expressions are called the quotient identities, and they are the tangent of an angle is equal to the sine divided by the cosine, which we did prove in class, and you can check back in your notes up there if you want to see how we did that. And then, of course, the reciprocal of that, the cotangent, if I flip this, would be equal to the cosine of the angle divided by the sine of the angle. So these two are called the quotient identities, and I'll show you how we can use these to simplify some trigonometric expressions. Alright, so remember, we want to leave an exact value, and we're not going to do these on our calculator. It's really the work that I want to see for these problems, not so much the answer. So, for my first example, I noticed that everything has the same angle. Remember, that was key. If I don't have the same angle, I'll need to do something about that. Well, what I remember is that if I have a sine divided by a cosine, that's really the same thing as a tangent. And so I can go ahead and replace this piece of my expression with just tangent. So let me rewrite the first piece. I have tangent of 20 degrees. I will then have minus sine divided by cosine leaves me with just tangent of 20 degrees. And so to simplify this, well, if I have something minus itself, that's going to simplify down to just 0. So this simplifies to 0 when I'm done with my expressions. Okay? So let's try a few more examples. Sometimes it may be useful to sort of do the opposite of what we just did, to take a tangent or a cotangent and kind of write it sort of more expanded out. So for example, cotangent, recall, was the same thing as the cosine divided by the sine. So let me rewrite cotangent of pi over 4 as cosine of pi over 4 divided by sine of pi over 4 using that identity. The sine piece then I'll leave alone for right now, so oops, times the sine of pi over 4. And I'm going to save this cosine piece and talk about that in just a second. So the reason that this is helpful, again, for using these identities is kind of like in the last video, I've got sine of pi over 4 and sine of pi over 4. So those will cancel out, meaning these first two pieces multiplied together are just the same thing as the cosine of pi over 4, okay? Well, I still have this last piece to worry about. I've kind of ignored that part of the problem. So cosine of 17 pi over 4. Like we talked about, we need to make, in the last video, these angles need to be all the same. So 17 pi over 4 is obviously not the same thing as pi over 4. So I'll need to adjust that. Recall our periodic properties for sine and cosine tell us that these values repeat every 2 pi or every 360 degrees. So I can actually go ahead and subtract 2 pi as many times as I want to, and I see that and I can pause the video and try this on my calculator, but I see that if I subtract 2 pi twice, I end up with just cosine of pi over 4 for this piece, okay? So 17 pi over 4 is really just the same thing as pi over 4. Since this piece was being subtracted, I end up with cosine of pi over 4 minus cosine of pi over 4, which of course simplifies down to 0 again. So there, again, the answer I don't really care so much about that answer. I care about using these identities to simplify these expressions. So let's take a look at one more example down here. Alright, I think what I might try this time is start with making all the angles the same thing. So I'm going to try to make them all 30 degrees. What I can recall about the sine function is that it's an odd function, meaning if I have a negative in here, I can really kind of just pull that negative out and make that a positive angle. So this first piece will just be negative sine or opposite sine of 30 degrees. So I have those two angles matched up. They're both 30 degrees. And if you need help with even and odd functions, I have a video if you want to search for that one. For the tangent function, again using periodic properties, I recall that tangent repeats every 180 degrees. So I can subtract 180 from that angle, which would leave me with just a 30 degrees there. So I've gone ahead and I've made all the angles the same thing. 210 minus 180 is 30. So let's see what I can do now using identities to simplify this even further. I recall that sine divided by cosine is the same thing as tangent. So since this whole thing is negative, I'm going to have negative tangent this time. So negative tangent of 30 degrees. And then minus the tangent of 30 degrees. Well, this time those two pieces do not cancel out. Instead, I can combine them and make this say negative 2 tangent of 30 degrees. Now normally I'd have to stop there, however I recall that 30 degrees is a special angle, so I can actually simplify this even further. Using the chart that we've made in class, I can look up the tangent of 30 degrees, and I see that that's equal to the square roots of 3 over 3. And so to finish this problem, I have negative 2 times square root of 3 over 3, which would become just negative 2 square root of 3 over 3. So I don't always get an answer of 1 or 0 like we've seen in the previous examples we've looked at in this video and the last one. But again, there's my properties being used to simplify this down to something much, well, simpler.